Hello, good morning, good evening, and good afternoon, everybody. So, so today we have left with a few topics. So we have seen what is the difference between a public cert, what is the phases, the 5 phases, and the optional phase, and the SSL handshake. And followed by that, today we finished until the what is Windows roots, no, sorry, Windows trusted roots certificate store, where you have to have your root cert for your successful SSL handshake for multiple applications. We have seen that, and today we will see what kind of errors we see in the record layers and how do we find, and we see the common errors if there is it is an expired cert. And I try to cover some use cases here. I couldn't get everything, but I'll explain. We have a capture for the expired cert, so we'll go through that. And in addition, I'll show you how to set up the decryption profile and how to decrypt traffic using Wireshark. That's an additional concept. No, that's not in the syllabus, but again, I feel that is helpful for you guys to troubleshoot when you do a decryption. So generally, when we say decryption, the TLS, it's a tunnel, and it's completely encrypted. When you don't see the layer 7 protocol, what is happening inside the tunnel. But when you decrypt, you get some additional information, sometimes what kind of application that's being used and what kind of HTTP request is going through. And if you have some problem to establish your connection, example, if I say, if you try to establish a connection, SSL connection with the Cisco website, an example, you can think of your own applications where you're trying to connect over the SSL, and the expected output you may not see in your HTTP request. So with the help of decryption, you have more insights, you can look deeper, and you can see what kind of application you are trying to see, and or your get request is going through successfully with your HTTP. So that level of information generally you don't see when it is encrypted. All it says is completely encrypted, and it may give you the protocol that's being used maybe in HTTP if you're trying to establish a connection over 443. But the decryption helps you, as I said, you will see what kind of HTTP request is going through inside the SSL tunnel. And this is supposed to be on the IPsec. This is for if you have a different security association, when there are multiple traffic, it's going. If you want to build two tunnels, and you can have only one crypto map in your outside interface. But what if I have a cloud, or it can be different, if you want to build a tunnel with a different remote destination. So in that case, how you're going to, I would not say tweak, and what is the configuration steps we have to follow to build multiple tunnels using the single crypto map. That's quite simple. It is something like an ACL. We have a different sequence number, and we have to create a different crypto map for it with the same crypto map. With the same crypto map, but with a different sequence number. Something like in the ACL, you got a multiple. I would say, what is that? In the ACL, you have multiple rules. Rule 1 is to permit something, source and destination. And the rule 2 can be your TCP traffic. So it's like a line by line. So it starts with top to bottom approach, a line by line. So in the same way, we create a different sequence number for in the same crypto map, where you can use the second sequence number is used to build a tunnel with other destination. So I'll show you the configuration steps, what we have to follow that. That is not actually the discovery lab, but I'll show you the steps to do in the IPsec perspective. And I mean, it's really, I think it's a bug with the viOS. I tried a lot, and I think this time it should be successful, hopefully, because I captured the traffic when it was successful, and hopefully it should work today. If not, I will definitely explain that. So hopefully it should work today. So I didn't touch the lab, because if I try multiple times, my IPsec tunnel is not actually, the negotiation is not happening. So ideally, the phase 1 tunnel is not not working most of the time. So I try to build a tunnel now. So I didn't touch anything. So I kept it aside to show you guys the UDP port 4500 when we are doing a NAT-T. So let me start with the NAT-T. We'll try for NAT-T now. And for that, let me open my lab. Let's see the negotiations that's going through now. Show crypto IPsec the same. It's good that we got done IPsec. Okay, show crypto. So running section NAT. And if you see a quick overview about what is this topology we are trying to achieve here. So we got two devices here. I'm just depicting this with the PCs. I just created a loopback interface for my IP NAT inside. So the traffic has to come from the IP NAT inside, and the traffic is trying to go over here. So over the IPsec tunnel, we are doing a NAT. So NAT generally will not happen, as I said. Let me quickly take my pen to I'll give a recap on what we discussed. This is one of the, I would say, the most frequently asked question, and everybody should know about that. What generally happens if you have your tunnels? Let me take this color. So when you actually build your tunnels example, so here is your tunnel. This is your phase 1. This is your phase 2 tunnel. And we all know that it uses UDP port 500. So that is a IPsec protocol. So that is common on both ends. We are doing some UDP port 500. So from the security standpoint, you cannot allow all the traffic. Example, in your ACL, I cannot allow the traffic completely between, so let's say razor. So this is 2.2.2.2. So I cannot allow all the traffic. If I permit IP from 1.1.1 to 2.2.2. So that is not the best practice of doing that, because I mean, even the unencrypted traffic, we are allowing it, but anyways, in the tunnels, that definitely it's not going to happen. But that is not the best practice when you implement something. So your security regulation should be very standard. So I would suggest you should just open the port UDP 500, because we are doing just IPsec, we are doing a tunnel, VPN tunnel, LAN to LAN. So I should open only the UDP port 500. So what if in my case, if I want to do a NATing, so what happens there? This is, as I said, this is very important question in your interview. So when you are doing your NATing, in the ESP protocol, we know that we discussed about this ESP protocol. So when we do a ESP, when we build your phase 2 tunnel, so inside this ESP protocol, you got your private IP address. So your interesting traffic. Let me take a different color that stands out better to differentiate. So example here, 2.2.2 is my destination, and this 1.1.1, the source coming from this guy. So this private IP address are purely encrypted. This IP payload is purely encrypted. So when I'm trying to do a NATing, it tampers the packet. So the ESP will not allow that. That's the whole point, the data integrity. So we cannot destroy the data integrity here, and the ESP doesn't allow to do that. So what happens, the ESP protocol, it creates a outer header, the public headers. In my case, the gig 0/0, I'll show you the IP address there. So we use as a source, and the outer header is 10.0.0.1. That's actually your public IP address. And here, if you see, that is 11.0.0.1. over here, this guy 11001, and here is 10001 is my outer header. So that is not encrypted. So I am going to do NATing. So what happens when we have discussed about this in the previous classes. Let me quickly fire up the PowerPoint to show you that specific option. So if you see this NAT-T, so NAT detection happens in your Diffie-Hellman, the nonce key exchange happens in your M3 and M4 packet, main mode 3, and this is a main mode 4. So here the NAT detection happens, and if you are doing a NAT, irrespective of it's from the initiator or responder, if the NAT detection happens, so it automatically tries to open the port UDP port 4500. So if your NAT-T is happening in the ISACAM negotiation, in your ISACAM negotiation, keep this in mind. So in your ISACAM negotiation in M3, main mode 3 and main mode 4 packet, the NAT should be detected and you should see the UDP port 4500. So I'll show you the log exactly how it looks. So if you actually see this, what color is that? If you look at this exactly, so it is telling that my outer header 10002, so it is trying to negotiate with 4500 because I'm doing a NAT-T here. So you should see this information. So when somebody is asking you, your NAT detection happens in your main mode 3 and main mode 4, when it tries to exchange its nonce messages. Nonce messages generally the Diffie-Hellman group session key creation. Both exchanges the key, and both has a public and private key. But with both the key material, it tries to create a shared secret, right? That's the whole objective of Diffie-Hellman here. So Diffie-Hellman got this is a source and this is a destination here. So they share something called as, we call this as a nonce message. That's actually the shared secret key. So it got a public key and it got a private key on both ends. You got your public key and you got your private key. Let me erase this. You got your public key and you got your private key. So both sides, it's a public and private. So using using these two keys, and it will do some mathematical algorithm and it will come up with a shared secret. And only the shared secret key is exchanged between the initiator and the responder. Only the shared secret key is exchanged between them. This is how the Diffie-Hellman works. We call this as a nonce messages in main mode 4 and main mode 3 and main mode 3 and main mode 4. So when this, you can see this is a key exchange. So when the shared secret key exchange happens between the source and destination, along with that, as I said, if we are doing a NAT, so it detects the NAT. So the NAT detection happens in MM3 and MM4, MM3 and MM4. So in the NAT translation, the expected output, you should see something like UDP port 4500 should be opened for that particular connection. Without tampering the traffic, only the outer header is used for the NAT translation. It doesn't tamper the traffic inside the private header. You should see something like this. If you see the from 10002, the UDP port 500, this is used for phase 1. And this is used for NAT-T. So you should see something an output like this. And what is the best practice of to allow this from the firewall perspective? I'll show you that how to do that. And now let's try to initiate a traffic. Before that, let me show you the config show run section NAT. So I just created the, as I said, show IP interface brief. So private IP address cannot be routed back. So I'm doing a NAT for the internal IP address. It's a destination NAT. So for my inbound traffic, whenever if this is the 1.1.1 right over here, that's hanging off on the VIOS router here. So that's a private IP address that's mapped to the public IP address because we are doing NATing with the outer header, not the inner header. So it's a simple NAT translation statement here, just to do the NAT process. And now let me show you that show IP interface brief, exclude unassigned. So you can see this loop back. So I created a loop back and I made this as IP NAT inside. And this guy over here is IP NAT outside. Section show run interface GI0/0. So VIOS box right over here, the middle guy he just acts as an ISP. We saw this topology back. So I know I'm doing all the default routes back to this guy, and I'm doing a default route all to this guy. Just we are depicting this as an ISP here. So this router is aware of the routing for both the devices, for VIOS and VIOS 5. For these two boxes, I got a route for that. I quickly open that and show you the routes. Show run section route. So I have a static route only for this private IP address here. Since these two guys are directly connected to this, so I'm not doing any routing for my outer header. I give show IP interface brief. You can see this the network, the 10 network and the 11 network. So it is aware of if you can give show IP route statement to see my route. So I know about one that's on the loopback on VIOS, and the public IP address is 10.0.0.8, and that is hanging off on VIOS, and the VIOS 5, that is 11 network here. So this is directly connected, so I don't need any route. So hopefully you guys are very familiar with the static routes now. So IP route. I'm not going to take much time out explaining this. If you show IP route, if you see this, 2 is directly connected, and my 11 network, I don't know anything about VIOS. I don't know anything about 1. So I'm completely leaning on the router VIOS 2 in the middle, the ISP, to route all my traffic back to the VIOS. That's a pretty simple design here. Show crypto, IPsec is safe. So the quick mode is in idle state, it's in sleeping state. So it's going through all the process. The phase 2 tunnel is up to verify show crypto IPsec. You see? So it's talking to the peer 10.0.0.2, the outer header over the port 500, UDP port 500. Looks good. So let's try to ping this guy. Let's try to ping 1.1.1. I can ping. If I can see NAT translation, show IP NAT translation. So if you can see now the NAT translation is happening for the port 160. If I give show IP access list, I didn't allow the traffic for IP header. even in the last class I have shown you, this is EQ non 500 is your UDP port 4500 here. So I just opened a port for 4500 and UDP 500 and I enable the ESP protocol. So I am not allowing all the traffic back. So definitely my NAT-T is happening. Otherwise, I should not see this output. So now let's try to clear the session. When it tries to do a NAT detection, it should happen. Debug, crypto, IPsec camp. Let me try to do for the outer header. Clear crypto session. Remote. This guy over here is 10 show IP interface brief 10002. Let me do it for 10002. Okay. If you see this, it's sending a packet for 10002 over UDP port 4500. So the destination port is 4500. If I try to ping now, you can see that the UDP port 500 is open now. So as I said, if you go back to this is very important. So where exactly your NAT detection happens in your IPsec tunnel and in the main mode 3 and main mode 4. So when you're explaining this, you have to explain with all this detail. And I am very confident that that's something you're giving a complete packet level, explanation to them. So how do we do this in the firewall? Irrespective of any firewall, the logic remains the same. You have to allow the same port. So access list. So access list include UDP. So if you look at this, I enable the traffic from this guy. I mean 192. Let me little bit track this down. Okay, my traffic from here to this guy, this is going through the firewall. Yeah. So I created a 2 contacts here. One is my DMZ context. So the other context is an outside. Outside context. You can see this, the traffic coming from 192.1.60.6 right over here. So I have done the annotation here. 192.1.60.0/24 is the WAN connection between this ASA and R6. And as I said here, right over here, the GI0/1, this is for DMZ. So I'll show you that. Show name as. So GI0/1 on the ASA firewall, this is for DMZ, and GI0/0 is for outside. So I have to open the ports between this outer header 192.1.60.6 right over here on this guy, R6, this guy. This is .6, and I have to open both ports. IPsec is a port 5, UDP port 500. If you see this is an UDP protocol, and this is DP 500. Let me try to highlight this better. So if you see this, this is UDP 500. And this is UDP 4500, right? So I have to open both ports, UDP 500 and UDP 4500. So this is pretty simple. And then if you want to do your troubleshooting with, if you're really doing your troubleshooting with your firewalls, and if you have to look into your ACL. This is for your IPsec camp. This is for your phase one tunnel. You should see the hit count right over here. You can see this hit count is 2 and this is hit count is 10. So my traffic is bidirectional. So from here to R4 and from R4 back to R6, I see the traffic back and forth for both my UDP port 4500 and ISACAM. This is just firewall rules we are going through. This is not in the discovery lag, but again, I want to show you guys in how to create a rules. I'm very confident that you guys are very clear with every single packet of IPsec. So this is how the implementation is same. This is a security box, but here we know that we have certain restrictions with the security rules. The traffic from the higher security zone to lower security zone, it is allowed by default, but the traffic from the lower security zone to higher security zone is not allowed. But if the traffic is going from higher to lower, it's not going to inspect the traffic back from outside to inside. But if you apply an ACL that breaks the rule, and if you have an ACL, you definitely have to have your permit statement to allow the traffic back. So I'm just showing this. So for every organization, the best practice, the enterprise devices, they have the security levels for sure, and they have an ACL attached to that interfaces. And this is how you have to create your rules. So you have to open up the port for UDP port 500 and UDP port 4500. And this is how exactly the NAT-T works. And you saw that, I mean, we have a crypto session, show crypto. Um, Again, it's not happening. I think we are giving a more burden to the IPsec, show crypto, IPsec camp, SA. See, my negotiation is not happening now. So when you're doing that, ensure that you are using a right image. From here, I can see this. I think it's because of a bug again. Can't see the security association. That's fine. So we have this QM idle state, show IP NAT translation. So now there is no translation here. If you try to ping again, I think it should work. IP NAT translation. So this how happens. As I told you, we are very fortunate that we saw that if my config is wrong, if it should not work, it should not work forever. But sometimes it works, sometimes it is not. But as I said, fortunately, we saw the output before. So that's how you should see your UDP port 4500 when the NAT-T is happening in over your IPsec. So run section crypto. So I have this tunnel, and along with this, I have a NAT, and it works. Section NAT. So when you're doing NATing, as I said, you have to open the ports 4500 for it. That's it really about NAT-T. So coming back to the few topics here, we have to see how the FTP traffic should go through, and how do I see the TCP sequences? How do I check the connection table? So that's a big difference with the router and the firewalls, right? Example. So I have created a telnet session for this guy. I think for R4. Let me quickly open the session for it, and I'll show you that. I think I'm on R4. Show run section BTY. So I have a telnet session opened for this guy. I give show IP interface brief, and this is 1.1.1. So I'm trying to ping from R6. This guy, I'm on R6 here, right over here. I'm on R6. So I'm trying to establish a telnet session, and it's through the firewall. First the basic ping connection 1.1.1. I can ping. Let me try to do a telnet for 1.1.1.1. So let me try with outer header. So I have a telnet session for R4 from R6. I'm on R6. If you can see this here. I established a telnet session, and in the ASA, I give show connection. So here you can see your 4-tuple connection. This is a state table, right? So the connection is coming from outside. It's listening on the port 23 right over here. It's listening on the port 23, 192.1.24.6. And this guy is a source 192.1.60.6. This guy is trying to establish a connection from the random port number 63195. So you can see the state table. So you don't have this option in the router. This is how the traffic flow happens here. So for the outside to inside, I should allow this traffic, right? If I have an ACL, definitely I should allow this traffic. Otherwise, the outside to inside traffic will not work. If I give show access list outside. So basically here I allowed all the traffic, IP, any traffic. So it's coming through, and you can see the connection table here. So it maintains the, the connection table, the TCP, full TCP connection, but whereas in the router, it is not like that, because if the same source and destination is talking only, then the return traffic is allowed. So in the router, it is not like that. It doesn't have the state table like this, like a firewall. So how do I open a port for FTP? If this is if we talk about the same topology design, and if I want to allow the FTP traffic, the traffic coming from the DMZ here, the traffic is coming from the DMZ. This is a DMZ interface, this guy over here. DMZ, and this is outside, this guy, and this is my DMZ. So how do I write the rules for this FTP? I think to differentiate, I have created one more rule for FTP, if I'm not wrong here. Yeah. So from outside to inside, from this guy 192.1.24.6, you can see this router, it's coming to this guy 192.1.60.6 router 4 to router 6 for my outer header. So I have opened a port for FTP, and it is always recommended to open the port 20 and 21, one for data and one for connection. So ensure that you open the port for both 20 and 21. So the traffic coming from outside to inside, lower security zone to higher security zone. So the traffic is not allowed by default. If you have an ACL for it, so you have to create a rule, something like this, to allow the traffic back. So we saw this ACLs to configure to allow VPN through firewall. That's something I shown you this. You have to open your port 4500, these two rules, UDP port 4500 and ISACAMP. For UDP 500, you have to open these two ports for your IPsec tunnel. This is for NAT-T, and this is for your phase 1 and phase 2, and your phase 2. And then I want to show you one more thing about the last thing here. If you're, the proxy IDs are sometimes when you use your, I think for the Palo Alto firewalls, they say it's interesting traffic you guys create is proxy IDs, I believe, if I'm not wrong. That's your actually your interesting traffic, and if you have multiple phase 2 essays, when there are multiple traffic selectors, and how do we do that? Let me go to this VIOS boxes here. Show run section, crypto. So example here, I'm just showing you how to configure. So I'm going to create one more crypto map. Sorry, I'm going to use the same crypto map because I can have only one crypto map, but I'm going to use a different sequence number here. If I see this is sequence number 10 and this is sequence number 20, and I'm going to create a session for it. So example, we got a peer, set peer, and example, my peer is something like 20002. Match address. So I have an ACL 102 for it because this is 101. I have 102. That's it. If you see my traffic now, show run section crypto. So basically now I got two peer. The first peer is 10.0.0.2 and the second peer is 20.0.0.2. And I have to create two more, I have to create two more, what is that? Two more lines of scripts to implement this because I defined my peer. So let me use a different color that stands out better. So this is so I got two devices. This is for R1 and this is for R2. My crypto map says I got a different peer, but here I have to create one more ISACAM policy for it. That's it. I'm going to use the same phase 1 parameters here. I'm going to use the same Diffie-Hellman group 2. It's going to use the same hashing algorithm. It's going to use the same encryption algorithm. But I can use even the same pre-shared key, but your address is different. You have to create your different ISACAM policy exactly. That's something I wanted to say that. So different ISACAM policy for your peering. So example, crypto ISACAM key. So I'm going to use the same key, but the address would be 20002. Show run section crypto. So you see this. So now basically what happens here, I got two routers. So one going for 10002 and one other one is going for 20002. If somebody is asking a question, so you may have only one crypto map, but with different sequence number and different ISACAM policy, you can build your tunnel. So this is your LAN to LAN tunnel 1. And this is your LAN to LAN tunnel 2. So I'm going to use the same phase 1 policy, but if you see the peering address is different, I'm going to use the same pre-shared key, but you can use a different pre-shared key. So it's just going to look into this. And if you just look at your IPsec profile, so you're going to use the same encryption and hashing algorithm. The only difference is you in the crypto map, with the different sequence number, you can just create your peer. So the first tunnel goes to R1 and the second tunnel goes to R2. This is how exactly you will achieve your config for multiple tunnels. We give show run interface GI 0/0. So I'm using the same crypto map, but inside this crypto map, I binded two tunnels. One for 10002 first tunnel and 20.0.02 is for my second tunnel. So you can build multiple tunnels like this with the same crypto map. That's the whole meaning of this. That's how you practically achieve that. Same config, no big changes. So only thing you're going to change is when there are multiple traffic selectors and if you're using multiple phase 2 essays. This is how you will define. You have to have a different ACL. The key, I mean, three key thing. I mean, if you see this ACL is different, right? So you're going to use the same phase 1 profile. Same phase 1 profile. So you're going to use a different pre-shared key, or you can use the same pre-shared key. Doesn't matter. But you have to create a different IPsec policy. It should be different. In your crypto map, your peering is different and your ACLs are different. So you have to focus on the three key materials when you build your tunnels. You can see this here. I'm using the same transform set. You can use the same transform set that's stitching your phase 1 and phase 2. The only difference is your pre-shared key because I'm making a peering with this. So that's how your negotiation happens with multiple tunnels, just with a sequence number in your crypto map. Because you should have only one crypto map. If somebody is asking a question and if you have a scenario maybe you guys have done, I mean, this is something I'm talking for someone who never did this. Multiple IPsec tunnels using the same crypto map. This is how you achieve that, because you may have only one crypto map in an interface, in the outgoing interface. This is how you achieve that. And coming to the decryption profile. So how to do that? Let me show you that. That's very quick and easy way of doing it. Let me show you that how to do that. So you have to do your let me show you this. So you have to go to your PC options, advanced system setting. If you see this advanced system setting, and you have to go to your PC advanced settings. You can see this PC and advanced setting. You're in the PC and advanced settings, and you have to go to the environment variables here. And if you see this, you can give any name, but it is better for understanding. You can give this. So you have to give a variable name like SSL key log file, and you can create just a notepad file. So if you open this, it is just a notepad file I created. You can see this SSL keys.log. I'll show you what are the information you will see over there. Just you create a variable name like this, and you you save a file in the notepad file. That's it really. And how we are going to bind this details. So you have to open your Wireshark. You have to go to edit, preferences, to go to your protocol, and you have to go to your TLS. And if you see this, I'm going to use the same path what I created in the environment variable. I created a file, the SSL keys log files for my decryption. And in addition, if you really want, you can create a file anywhere. Those debug TLS debug files will be saved. I'll tell you what is the use of it. I'm just give a name. As I said, you can create a text file anywhere. You can just bind it over here. I just created the same file and just binded this. So done. So once I do that, in your actual traffic, you cannot see what's going on inside your HTTP. Because if you see this right over here, this communication is happening on destination port 443, right? The source port is 21483. I'm trying to connect to Cisco, but I don't know the website because that's completely TLS encrypted. I'll show you that without only in the TLS, what is the information you will see. But right over here, if you see this, I can exactly see what is inside my HTTP header. So it's trying to connect to community.cisco.com over the port 443. So this is because of decryption. We created a profile for it. When I try to open cisco.com, we'll try this one more time. Just for your explanation, I'm telling you this. With the pre-master secret, it is decrypting. So I will show you how do I see the pre-master secret and how it is created. How, what is the use of pre-master secret. So if you see this, if I give pre-master should see the pre-master, it's encrypted or what? Secret. Okay, fine. So see, this is all my pre-master secret keys that's been saved inside the same file, SSL key log file. I saved everything. It is inside. That's why it is doing the decryption. So for every session you open for your SSL, your pre-master secret will be saved right over here. So coming back to this, that's something if you try for pre-master, actually it should show. I think I am doing some case sensitive value over here there, but we'll come back to that. That's not the concentration here. So the whole point is we want to do a decryption. We have to see the traffic inside that. So if I say decryption, you cannot see all the data going over, but you can see what is the protocol, layer 7 protocol inside. So when we go to the TLS, we don't really see this, right? So this decryption is actually happening because of the profile, and you can see this, even it does the reassembly of messages when you do a decryption. That's an advanced way of doing it. For now, we're just focusing on just the SSL decryption, how it happens. So I can see the layer 7 traffic, what is going inside. That's generally you will not see without decryption. So how it looks without decryption, I'll show you that. If I give TLS, so this is without decryption. So we are not doing any. So the yellow packet defines the decrypted packets. If you see without decryption, so inside my TLS packet, what it just says an application data. So you can see right over here, it is just telling you that this is we are using HTTP protocol. But do we know what is inside this HTTP protocol? What application is being used? What website I'm trying to see? I don't, because that's completely encrypted. You see that one message says it's completely encrypted. So when you're troubleshooting, this decryption policy helps a lot to see actually what application is being used. Because in Palo Alto's the next generation firewalls, it can be any next generation firewalls, you will open a port 443, not for everything, not like ASAs. You'll be very specific. Example, the port 443 is open only for cisco.com, not for google.com. You can do a restriction like this. So you will do this application inspection. So I allow the port 443 for cisco.com, not for google.com. But with the help of that decryption profile, you can see if you allowed cisco.com, is it my decryption is actually working, and I do see the cisco.com inside my decryption, inside my decryption, I can peel off and I can see this particular application is talking to cisco.com or not. You can use this for multiple troubleshooting. So whole point is you can see the layer 7 traffic right over there. Whatever the application you're exactly using, and you can see this application. So that's the use case of decryption. Let's try to do this decryption when we are doing it. I mean, when we try to open the same website now for testing. Let me close this. Let me open this. Let me start the Wireshark. Let me try to inspect some traffic in my Wi-Fi. Frames contains Cisco. I am trying to open a Cisco website. So you can see this. Okay, stop. So exactly, I can see Cisco tax.cisco.com is a website we are trying to open inside my HTTP here, right over here. Right? I can see this traffic that's going on from my computer, and this is to the cisco.com. Yeah. So this is how the decryption works. Otherwise, you cannot see this traffic, what's going inside. So you can see what is the requested URL right over here, cisco tax.cisco.com over port 443. But when I do the TLS, conversation filter TCP, if I take just a TLS traffic without decryption, so what should I see here? Inside my TLS, in the application, it just shows me the hypertext transfer protocol. I don't see what is the URL it is trying to use, what is the application is being used. So that's a whole point of decrypting your traffic. This is how you will do a decryption. You can use the same. You can use the same profile for your troubleshooting. And coming back to this fatal error, coming back to this common certificate errors, where do we see that? I have a capture for it. That's something in the real time. It's hard to do that because we have to create a certificate with that. So I have a capture for it. I'll give you all this capture for you guys to practice. All the config, what I created for this IPsec NAT-T. No worries with that. So to quickly find, so I always use a filter TLS dot handshake dot certificate. Should apply this. I think it is reassembled. I'm expecting to see the bad certificate warning. I think let me close this. I should see that. My alerts, there is another way of doing it. This for a connection reset. I should see the warning right over here. Yep. So it is telling that it's a bad cert, the warning. So right away, if you see here, after this message, yeah, this is your client and this is your server, yeah, CS. If you see your certificate with hello, it's 104 is the server. So the client, it says 103, the client, it says 103 is a client. Let me use a different color, stands out better. This client and this guy is a server. 104 is a server. 103 is a client. Right away, this guy is telling that this guy is a bad cert here. So this is a certificate warning. Right away, you have to go and check this cert. How do I check this cert details? You can see the description. Yeah, you can see that in the TLS record layer, you will see this bad certificate warning. So you can see right away what cert is used here. So in the client hello, certificate exchange happened right over here. So you have a certificate validity in the subject cden.chetest.com. So it is telling that this is signed by GeoTrust and yeah, the organization unit is www.geotrust.com, and this certificate is your client. Your client is not going to trust this certificate because it says it's a bad cert, and the client right away it resets the connection. It's not going to continue this for the communication over the TLS. Even though this is very important. See, you should right away whenever you have this problem. So this proves that your firewall ports are opened properly. You do not have any problem with the TCP connection. This is a problem with the certificate. The same way in the warning, right? So in the warning, this is you can. I always prefer this the quick filter, the powerful filter right over here in the left corner. You can see all your reset messages, your Cincinnati messages, time to leave, a lot more. In the good thing about this is this integrates everything by section by section. So you will see all the resets over here. You can see all your HTTP packets here. This is a quick way to find what exactly I'm looking for, what I am interested to check. So if you see this, this is something very hard to replicate the other things, but in the same record layer, you will see the unknown cert. You will see the untrusted issuer. You will see in the certificate, we saw the issuer, right? Where is that in the record layer? I saw that. TLS. It's a fatal warning here. So what are the key fields you will see inside your TLS in the certificate? So it is telling that in the alert, it says bad cert. In the server hellos, in the certificate exchange, if your issuer is unknown. So here, who is the issuer here? So GeoTrust is the signed certificate. This is the guy who signed the certificate. This is a public root CA. So you may not have this particular root CA certificate inside your computer. That's the whole meaning of this. So we saw the bad cert, and if it is an expired cert, you can see your validity right over in the certificate. You can see your validity, you can check your validity. So this is an expired cert. And if you have your expired cert right over here, in the same record layer, you will see the alert saying that it's an expired cert. If it is a common name mismatch, see, this is a common name, right? So this is a common name ID. I'll take a different color. Chess.com. So if you see the common name mismatch, then the certificate is signed with a different common name. If it is a revoked cert, you will get the warning. Everything you will see this warning in your fatal warning. You will see that. So when you're troubleshooting, you have to your focus is mostly on your record layer. It will show all kind of warning. Even I have seen a scenario where I have seen an unknown CA. So if the particular root certificate, you do not have that root certificate, your SSL handshake will not happen. We discussed about this in the last class and we saw that. See, when I'm trying to open a connection with google.com, I should have that root certificate in my computer. In the last class, we discussed about that. If I don't have the root certificate of google.com, it's going to throw an error saying that it's an unknown cert. Even in this connection, if your computer doesn't have the root CA who signed this particular certificate, I should see the warning, right? So I cannot establish a connection because I don't have the root certificate in my computer, so it's not going to trust my connection. So I will share all the documents. As I said, the configuration document, the step-by-step procedure to build the SSL decryption profile, and I'll give all this configuration, whatever I created here, the configurations to open the ports and the firewall configuration, and I'll share the screenshot along with that so you guys can practice at home. So it's actually a wonderful experience for me to meet you guys, and hopefully I have given the enough information what I am aware of, and hopefully I think you guys understood better. If you still have any questions, you can you can ask your questions in the common WhatsApp group. Apart from that, if you guys have any other further questions, then you're feel free to ask your questions now. Let me stop this recording. So guys, if you have any questions about today's class, you can ask me.
Hello, Praveen.
Hi, Deepa.
Praveen, I have one question regarding IPsec tunnel.
Mm-hmm.
Means when you have created two tunnel, so can I create like this way? Like one would be the primary and other would be the ideal. Means when primary tunnel. Uh, means like this we can create or both tunnel will be active at a time.
I mean, you mean to say creating a different tunnels using the same crypto map is the one you're talking about?
Is it not possible, right?
No. I mean, with a different sequence number, as I said, yeah, definitely you can create, but with it should be for the different peer, not for the same peer. Example, you take this example. You have your firewall for all your IPsec. Okay, that's the not the hub. We should not say that is a hub. That is the transit point for all your IPsec tunnels. So you have a firewall for your IPsec tunnel. So your tunnel transition point for every router, you got 10 routers, and your firewall is the transition point for all the branches. Example. So in that case, in the firewall, you have to create a multiple sequence number with the same crypto map, because the outside interface of the firewall, that is the tunnel, that's the that's the interface used for establishing your tunnel with other routers. But you may have a multiple crypto, sorry, you may have to create a multiple sequence number with using the
That
same
means,
crypto map. It's something like an ACL. It's something like an ACL. As I told you, you can use the same crypto map, but with the different sequence number, you can build as many tunnels you want.
yeah, that I understood. But that means every tunnels are active at a time, right? Means two tunnel you have created. That means two tunnels are active
Yeah, yeah.
at a time, right?
Correct,
Like this.
correct, correct, correct. From the firewall,
So,
yeah, I got two
uh,
tunnels here.
uh-huh.
Correct.
So can I achieve this type of scenario? Means I want this type of scenario. Okay, I have created two tunnel.
Mm-hmm.
Okay, but one would be the primary, which will be used. But when it will be down, that time secondary will be active. Otherwise, secondary will be the ideal.
I don't think,
Yes.
see, this implementation is for different. I mean, I would say this is different tunnels. No, I don't think you
Oh,
can create a primary and secondary tunnel for that, because I never tried that. This is for
okay.
multiple routers, and I would say this is for different tunnels, multiple tunnels, not for the
Okay.
same tunnel active passive state. No.
Okay.
Yeah.
So peer IP will be like it.
So your voice is breaking, Vijay. Vijay, right? I just heard half of it. Peer
Sorry?
IP. Yeah, yeah,
Yeah. Now it is audible.
yeah. Now you're audible. Yeah.
Okay. So for example, if you are taking one project, let's take an example as a Podison project. Okay.
Mm-hmm.
So if they plan to opt for the two tunnels, obviously the pair IP will be different, right?
Correct, correct.
So
Yeah.
so one pair IP, if it goes down, the client will recommend it to as a DR. They can go for some other tunnel, right? So Deepa, are you referring the same thing, or like you're referring some other different thing?
Could you repeat again, Vijay?
So there are two tunnels is there. Let's take an example. One project. Okay, you're working on project is a Ford. Okay, so your client will be in US in one location. So other client will be in London. Okay, so we will build a one tunnel. Okay, so for the primary would be a London, the US location. The secondary tunnel will be a London location. So the your source will be a. I mean, you can take it as a, your source is a one pair IP, source pair IP, but a destination. So destination pair IP. So US having one pair IP, that will be a primary tunnel. The secondary tunnel, as you said, if it is in idle, okay, if the primary tunnel goes down, immediately the secondary tunnel needs to come up automatically. But we can set the priority at the time, even though the manual failure needs to be there, right? So if the primary tunnel goes down, okay, obviously the secondary tunnels to take in place. So we can set the priority, and then you can make the, if the primary tunnel goes down, you can get the secondary tunnel as a priority, even though if it is idle also. That we can achieve, I think.
Okay, to set the priority.
Sorry? No? Priority. Yeah, priority. Correct. On the priority, so we can set the priority. For example, default priority for one of the your pair IP will be a 5. Okay. If you can set the secondary pair with the priority 4 means, okay, that secondary pair will be taking care. Okay. So those things you need to like do it manually. You need to manually. So you to avoid this one, so there is a concept BFD and all is there. We can achieve. Okay. So we can achieve that.
Okay.
So if the primary goes down, secondary will take it automatically. But the thing, right? Different pair needs to be there, as Praveen suggested, right? There should be a different pair. Primary peer will be in some
Okay.
different location. Secondary peer will be in some different locations that you can achieve.
Okay. Okay. Thank you.
Thank you.
So, Praveen, I have a question. Like in ASA, if we are using phase one proposals in multiple peers, so how can we verify that we are using same phase one proposal in different peers? How to verify that?
Same. I think in the firewall you'll be creating your tunnel groups, right? For different peers. You create a different tunnel groups, right? For every peer, if I'm not wrong.
Okay. So for different tunnel, we are using different proposals as well, right? Proposal number 10,
Yeah.
20, 30.
Yeah, I mean, as I shown you, you should have a different peer IP for your IPsec camp policy, and inside your crypto map, your peer IP will be different. But you can use the same transform set. Transform set is for IPsec because for the IPsec tunnel, you're just doing your encryption and hashing.
Yeah. But for how to verify that we are using same phase one proposals in multiple peers?
You can give show run section tunnel groups. Maybe in the tunnel groups, you will have the proposals for every different the peers, right? What are the peers you're going to create? So you will see the proposals for every peer what you're using it, right? It depends on the tunnel group what you create. You're giving a tunnel group a different tunnel group. If you want to create different policy, that differs. I mean, if in the router, if you ask me, I have shown you, right? I mean, for the same, you can use the same phase one security parameters, but your IPsec camp pre-shared key also can be same, but your peer should be different. And you can use the same transform set, same IPsec profile, but in the crypto map, you have to create a different sequence number, different ACL because your interesting traffic is different. And along with that, what else? Your sequence number is different. That's how you differentiate your tunnels.
Okay.
In the ASA specific, I have to go look back again because I think it should be the tunnel group because I have to look into it and I have to give an exact answer for it. I may tell you in the chat.
Yeah, please, because I also don't have the ASA permission right now. So that is the reason this question came into my mind.
No problem. But if you ask me the router, because we did the implementation of the router for multiple tunnels. So from the router perspective, yeah, your IPsec camp policy with a different peer, you can still use the same peer. Sorry, you can use the same pre-shared key, but your peer should be different in the phase one. And in the phase, your ACL should be different and your crypto sequence should be different. That's how we differentiate. This is a second tunnel or it is your other tunnel going to a different destination.
But we created the tunnels in between the routers only or in between the routers and firewall?
No, it's between the routers. So firewall is just we're just looking into the rules that is needed for a firewall to allow the IPsec traffic. So we have to open the UDP port 4 and 500 and 4500.
Correct.
That works for all kind of traffic, whatever you're doing it, because everything is in the phase one. It's encrypted and it's it's passing through the UDP port 500. And if you're using NAT-T, you have to open UDP port 4500.
But if you try to configure router and the firewall, the tunnel is formed, right? So this one, because like my miss that sorry.
Yeah. Tunnel was established. That's why we see the hit counts for IPsec.
Okay, from router to firewall, you meant to say, right?
Yeah.
Super. Okay. So there are two tunnels we created in the router and the firewall also we created two tunnels, correct?
Yeah, correct. Yeah.
Okay.
Also, one more question, Praveen. Like you are showing one error, like certificate error. So suppose in production environment, if some user are facing the same issue, so how we are going to remediate?
What
Like
issue?
it is showing like certificate error.
Oh, certificate errors, then you have to check for your certificate. You can say that is a bad certificate. I mean, it can be, I mean, what kind of error
Yeah,
you're actually looking at?
like there is no certificate in the user system. So how we can like sometimes users facing this kind of issue like bad certificate error and they don't have any certificate in their system. So how we can remediate that issue in
Yeah, as I
production?
said, see, that's what, see, bad certificate is something, it deliberately it says that it is corrupted certificate. That's not the good certificate. See, if that's what I said. If you're in your record layer, if you see something like common name mismatch, then whatever the CSR you created and what is your actual cert, the common name, there is a mismatch with the common name. You can tell them the common name, I see the common name mismatch. You have to give your new certificate with the proper common name. When you created your CSR, the same common name example, if I give google.com, I should also get the same certificate with the common name google.com. And even if I say googles.com, or if there is some errors with the spelling, then that's again a common name mismatch, right? You got it? If you have your certificate with the common name mismatch, it's about what kind of error it displays. So here it is telling that bad certificate, that's corrupted certificate. You have to tell them the certificate is a bad certificate. You have to create a new certificate and give it to me. And if you say it is an unknown certificate, unknown CA, then you have to install that particular CA. You have to see inside the cert who signed the cert. You have to install the same root certificate in your computer. That fixes your problem. So that depends on the scenario, what kind of error it displays. From there, you have to do your troubleshooting.
Okay, got you.
Yeah.
Thank you.
No problem.
Just I have one question.
Yeah.
So just if you can explain, because like I'm facing this particular thing in my organization.
Mm-hmm.
If any user generated a traffic, right? Okay,
Mm-hmm.
it'll goes to firewall. That will be like Palo Alto or checkpoint. Okay,
Mm-hmm.
some other firewalls also we do have. Okay, but the thing, right? All the traffics from, for example, if I'm trying to access one iccbank.com or like accessbank.com. So the certificate in my browser from a mobile or like in my computer, so it shows like the respective the company certificate, company owned certificate, the banking certificate. But the thing, right, when I'm trying to access in my organization, I'm getting the respective firewall to own the certificate. So all the traffic that is decrypting, and then only the traffic is passing from my firewall.
Then
Okay.
you're doing
So,
something like forward proxy.
yeah, in between proxy is there. In between proxy is there.
Yeah, then
So
apparently your TCP connection, your SSL connection happens for your proxy server, and from the proxy server, your connection goes to your actual destination, your ICICIbank.com or accessbank.com.
okay, so how that is like configurations can take care, whether like in firewall that configuration needs to take care, or like from the proxy level that needs to like achieve.
No, actually, we have a WAF. In this scenario, that's a bit different. We have a WAF in the middle. So what happens? The client comes for a connection, right? The client comes for a connection, and they don't see actually the certificate of the server. They see the certificate of the WAF. So they should have the certificate, root certificate, which is signed for the WAF. So they should have, example, it is a DigiCert or whatever. So if they have the certificate, they can still establish a connection. In that case, we cannot see because here the key thing is, if there is a proxy in the middle, then it depends on what kind of connection you allow between your WAF and your actual destination, and from the client, what kind of traffic you establish from your client to the WAF, or maybe it can be a firewall also. Is it SSL? If it is an SSL, then definitely, if, as you said, they should have the root certificate which is signed for the firewall. They should also have the same certificate. So the whole point is that's the reason everybody cannot own the system cert, right? System cert is certificate that's given for that particular device, but instead everybody who tries to establish a SSL connection, they should have the root certificate of the system cert. Example, for the google.com, GoDaddy is signed the certificate. So I should have the GoDaddy certificate in my computer to access the google.com, because I trust google.com because I have the GoDaddy certificate in my computer. So I am going to believe this, okay, this Google server is signed by the GoDaddy and I have the GoDaddy root certificate in my computer. That's how we trust the connection. So it's purely based on your root cert, because every system cert cannot be installed. So the whole point is we should definitely have the root cert. So the 95% of all the root cert is pre-installed in the computers. And if you don't have it, you have to install inside your Windows Trusted Store. That's when your SSL connection establishment happens successfully.
For example, let's take an example. So in your computer, GoDaddy certificate itself not there.
Then definitely I cannot establish a connection.
So it lasts to like a whether like you need
this site is not secure. For him, it says it will not trust, because I don't trust, because I don't have the root certificate. So I don't trust the site. Yeah.
Okay. So for example, if in that organization, so the firewall is showing, the certificate name is a firewall name is showing there. Okay. So in that scenario, so the firewall itself decrypt, and then will it download the certificates to the local computer or something else? Okay.
I know the decryption profile, it will just try to see the traffic, what is inside. That's what I know about the decryption logic, but it will not download any certificate for sure.
So okay, so
it will look for the information inside. Yeah,
information
inside. Yeah.
So information inside, it will decrypt, and then it will try to allow for the it will try to establish the connection, right?
But to be honest, I am not very familiar and mastered in firewall decryption, to be honest.
Okay. But the thing, so root certificate is a majority.
Yeah. Correct. To trust. Yeah.
Okay. Thank you, Praveen.
No problem, Ajay. No problem. Yeah. Okay, guys. So if you have any further questions, you can ask me, or else we'll wrap up this call. Vishal, we can't hear you. I think you're trying to speak to us. You guys can hear Vishal? No, right?
No problem.
Okay.
We're able to. You're audible.
Okay. Thank you. Vishal, you can disconnect your mic, and you can connect again. You can give it a try one more time. He's trying to connect again. Yes, Vishal, you can unmute, and if you have any questions, you can ask me. No questions? Okay.
Hello?
Yeah, hello? Yeah, Vishal. Yeah.
Hi. I don't have a question, but I would, today's our last class, right?
Yeah, today's our last. Yeah.
So I would like to say thanks for all the efforts you have taken for teaching us all the topics.
Oh, thank you so much. I'm very glad to hear this feedback. Thank you, Vishal.
And also, I hope we will get the slides for the.
Yeah. For sure. I'll share the slides. I'll share the config and everything. Sunday, you guys will definitely you'll receive.
So it will be on Google Drive, or what exactly?
Google Drive. The same Google Drive I have added. I think earlier you got few slides or documents from me, right? It's over the Google Drive. I have sent out a few documents, but have you got those documents before?
No, if you send the link again, it would be helpful in
Yes,
WhatsApp group.
if you can send
Okay.
that, very good for us.
Okay. So you guys can
Also,
tell me, okay,
just
you.
guide us.
Mhm.
Also, just guide us for the lab which was rented out last time you showed us, right? I don't
Okay.
remember.
Yeah. Vijay also asked me. Maybe Vijay and you can schedule a session maybe in the weekdays for sure. We will schedule some time and I'll show you. That's not a big thing. I'll give you the contacts if you want. You guys can use it. You
Okay.
can call them and I think the pricing he will decide. I just rented for 1 month because my computer is not very sufficient for running the firewall. So I had a problem. So I've rented a lab for a month. I think Ali is a guy, he gave the contacts for it. So no problem. I'll give the contacts to you guys if you want. You can talk to him and you can rent the lab.
If the Google Drive link is handy, you can just paste it here in chat. I'll make a note of it.
No, actually, I didn't upload those documents in the G Drive.
Or else you can share it on WhatsApp later on. Not an issue.
Yeah, sure.
Okay. Thank you again.
By
Thank you.
Sunday, yeah, sure, Vijay. Sure, Vishal, sure. Thank you. Okay, guys, I would also definitely thank you guys because you guys asked many questions that made me to think a lot, to research a lot. That helped even for me because I try to cover everything. And also, I would thank my team members, Hemo and Vidit, for this. This is I feel this is a fantastic course curriculum I have seen because it has a lot of details for every single protocol. And I hope everybody, if you guys can master this, and I think that helps really a lot for your job, troubleshooting from the interview standpoint. That definitely, that makes you different, and you will definitely stand out in the competition for sure. I'm very confident about that because the level of the content for every packet what they given that is really fantastic, I would say.
That's true, Praveen. So the way and then you're putting efforts, it was like mass. The thing, right? It was amazing. So each and every topic, right? So the way when you're representing, right, theoretically as well as practically, it was like a very useful part of day-to-day operations. So we are able to grab what are the steps you are covering, right? The thing,
Yeah.
right, the thing that few classes only I was missed due to some of my personal reasons and my shifts probably. But the thing, right, the topic, whatever the topic if you're covering, right. So the moment one day if I joined also, I mean fifth day if I'm joining also, it was very easy for understanding the things. Okay. So thanks, Praveen, for the day-to-day
Yeah.
operations. I hope like everyone use the content, okay, forever.
Yeah, sure. We will be
It
in
was
touch. We will be in touch for sure. I mean, if you guys have any other questions in the chat, maybe I'll try to answer. Even if I have any questions, and I'll be asking you guys. Yeah, for sure. It's about
personally
the
the one
mutual
thing I
learning.
wanted to convey the way you are explaining, right? So it
Mhm.
was very, I mean, the language, okay, it was very good, Praveen. Okay,
Okay.
so I'm very impressive the way
Okay.
you are explaining.
Thank you, Jay. Thank you for your compliments. Yeah, thank you so much. And Mario,
Yeah, Praveen. So regarding the NAT traversal, I'm okay with that. I have no question.
okay,
And yeah, so I never saw in Wireshark, so thank you.
okay,
But I know the subject. And regarding the whole course, I really want to thank you again for the effort and the passion for the answer and the question. So I'm very satisfied that I think I will write a comment also in the chat. So I like it very much the
thank you.
course. So
Because
thank you.
I know your expectation is too high, and sometimes the questions what you ask, you will be silent most of the time. I think you're familiar with most of the topics what we discussed, if I'm not wrong, correct?
Yes, but I never saw from a troubleshooting point of view and from a packet capture point of view. So this is why I was interested in the course. Yes, and actually I would like to attend also some other course because I like this, but I found that the most of them are at impossible time for me because of the different timing. Yeah.
Okay, no problem. So you guys have a recorded session you can watch multiple times. That's the whole objective of doing the recording videos. That's very helpful for everyone, not only for my videos, right? So whenever we buy videos and it is a recorded video, so you can watch as many times you want until you feel happy with that, or until you get the full satisfaction of learning something.
Yeah. Okay. So thank you again.
Thank you, Mario. Yeah, sure.
Really nice course for me.
Yeah,
thank you.
Sure. Thank you. So which Raju. So Deepa, you got your all the labs. You got few problems with your labs, right? And how I hopefully you did all the labs and you had few.
But till now,
difficulties.
some labs are pending. I will do in future.
Okay.
Last class, anyhow, I missed due to some problem. But yes, for me also, your class is very helpful for me. Before I didn't understand how to see the packets in Wireshark. Okay, so after watching this, I can understand now. And if I see your recorded video again and again, it will be sure I will be more good in my present situation.
No problem. Yeah, sure. Yeah.
Thank you.
Yeah, no problem, Deepa. Thank you. Thank you then. So Yamuna, you're good. Hopefully you are try to join all the classes, right?
Yeah. Right, Praveen. It was nice session, and I'm more clear and thorough with this Wireshark. So
Great.
now how to check, because I was most of the time I was lagging how to use this Wireshark. Now I am confident.
Okay.
Because of you and your so much wonderful session.
Okay. Thank you, guys. Yeah.
So hoping be in touch, and we will connect if I have any doubt.
Sure. It means a lot, guys. I mean, thanks so much for your feedbacks. Yeah, but definitely I worked really hard to do this because every packet level I did a lot of research doing that. I hopefully everybody is not perfect, but I'm trying to. I try to cover as much as I can, and that, as I said, it means a lot. Then even if I have any further documents, and Mario asked about the capture. That's something I'll try to give a capture, Mario. There you can do a UDP.port equal 4500. You should see that. I'll try to share the PCAP in the G drive. And if you have any questions, you can ask me. Yeah, that's something. Yeah, I didn't do that. The problem is, the biggest problem with this VA is what I had. It was really terrible for me. I don't know. It's my fate or something. It played a lot because I tried almost for 30 hours, and sometimes I felt it's completely wrong. And even I tried from a different perspective, line by line. I checked, and everything is properly done. You can see that even today, the phase one tunnel goes down. If the tunnel negotiation, if my security parameters are incorrect, I should never see my phase one tunnel coming up, but it comes up. I don't know, it's because of a bug or something. It goes down to show the UDP port 4500. I mean, I tried a lot. I mean, that fortunately that worked today. So that's why I cannot do that Wireshark capture, but I would have done. That's fine. But I will take a capture and I'll send it to you, and I'll show you the filters, how exactly you can do that. That's very simple. You are very familiar with that, the Wireshark filters. I'm very sure about that. So you can do UDP.port equal 500 and 4500. You can see this NAT-T happening with the outer header. I'll show you that. I mean, I'll
Yeah.
send the details in the WhatsApp. Yeah.
Okay. Thank you, Praveen. Thank you.
Yeah. No problem. Okay, guys. So have a good future and do well. If
Okay,
you have any
Mr.
interviews,
Praveen, Mr.
do
Praveen,
well. Yeah. Akbar. Yeah.
Akbar with you. Thank
Yeah.
you for this session. It was a very good session.
Okay.
Even though I could not attend most of the session, but I'm sure your explanation are well. Thank you.
Okay.
Thank you very much.
No problem,
Okay.
Akbar. Thanks a lot for your compliments. So yeah, as I said, guys, crack the interviews, do well, be good at what you're studying. So one piece of advice I would say is you do your labs, don't give up until you find an answer. You do it every packet, you try to learn. That's it.
Okay.
Then nobody can stop you. You can answer all the questions. Whatever you learn, it can be any technology. But my piece of advice is something you have to do the lab for sure, and you have to investigate. It should be 100%. When somebody is asking a question, you should be 100%. There is no way of thinking about that. You have to do a lab. You have to master yourself, and yeah, crack your interviews
Okay.
and
Okay.
get good jobs. Yeah.
Thank you very much.
Thank you, guys. Yeah.
Okay.
Have a
Thank
great
you.
day then. Bye.
Okay. See you.
See you. Bye.